Complex numbers. Now looking at Argand diagrams. An Argand diagram allows us to represent complex numbers visually, where we have the real axis, allows us to show the real numbers, so those include the natural numbers, the integers, the rational numbers, and the irrational numbers. By rotating this 90 degrees, we end up with the imaginary axis, so effectively giving us two dimensions for our numbers. So the real along the x, the imaginary along the y. Hopefully remember that I is equal to the square root of minus 1. So for example, the square root of minus 4 is the same as the square root of 4 times the square root of minus 1, which is equal to 2i. So, on our diagram, if for example we look at the point Z1, we move left by 4, up by 1, so that gives us minus 4 plus 1. For Z2, we move across 2 in the real axis and up 1, 2, 3 in the imaginary, giving us 2 plus 3i. And finally Z3, we move 1, 2 across in the real and down 3 in the imaginary, giving us 2 minus 3i. So, in general, complex numbers can be written in the form, and we quite often use the letter z, in the form x, which represents the real part, plus I, denoting the imaginary part, with y. Sometimes that can be written as y times I, the other way around. So really we can think of these as a complex number can be expressed as a vector. So for example, the point z1 as a vector could also be thought of as minus 4, 1. Example 1. Show the complex numbers z1, z2 and z3 on an Argand diagram. So here you can see an Argand diagram where the x-axis is the real numbers and the y-axis is the imaginary numbers. So combining those gives us the complex plane. So z1 is minus 4 plus I. Z2 is 2 plus 3i. And finally, Z3 is 2 minus 3i. Sometimes we can think of those complex numbers as being represented as a vector. So for example, the vector Z1 would be as such, going from the origin to the coordinate minus 4, 1. Z2 would be represented by this vector, and finally Z3 would be represented by that vector. So it can be helpful later on to think of these as vectors, particularly when we want to add, multiply, subtract or divide with them. Example 2. In this example we have Z1, Z2, and we want to show Z1 and Z2 on an Argand diagram, but also Z1 plus Z2. So Z1 has 4, 1, so we can think of that as Z1, which if we were to think of it as a vector would be the following vector. Then we have Z2, which is 3 plus 3i. And if we were to think of that as a vector, that would be the following. Now, we want to find Z1 plus Z2. To do that, we can think about vector addition first of all. And doing that, we can think of it as being taking the vector Z1 and adding it on to Z2. Alternatively, we could think about it as taking the vector Z2 and adding that on to Z1. And what you'll notice is we get to the same point. So this point is the point Z3. Now that's using a vector method. Alternatively, we could think of it as being Z1 plus Z2. Well, Z1 is 4 plus I. Z2 is 3 plus 3i, which gives us, adding the real parts gives 7, and adding the imaginary parts gives 4i. And here you can clearly see, move across 7 and up 4 gives us Z3. Example 3. Here we have Z1, Z2, and we want to show Z1 and Z2 on an Argand diagram. However, we also want to show Z1 take away Z2. So let's fill those in. Z1 across 2 up 5, labelling that Z1. Z2 across 4 up 2, labelling that as Z2. Now let's consider those two as vectors. Next, we want to find Z1 take away Z2. Well, we can think of that in a selection of ways. We can think of it as Z1 take away Z2 first of all. So let's think about that as a vector. So if I take the vector Z2, however, you'll notice we're subtracting this time, so that means the direction of the vector changes. So if I Z1 to Z2, this indicates that we will get to this point here. Or we can think of it as it is minus Z2 plus Z1. So again, we could think of it as the vector Z2 changing direction because of its negative. And if we start off with negative Z2 and then onto that we add the vector Z1, and notice we get to the same point. So this is the point Z1 take away Z2. Alternatively, we could think of this in terms of just writing the numbers out. So Z1 minus Z2 is equal to 2 plus 5i subtract 4 plus, and using brackets is important here to keep our directed numbers. So we have 2 take away 4 gives minus 2 in the real part. 5 take away 2 leaves us with 3i in the real part. And as you can see, minus 2 plus 3 is our answer.